Everyone, today we are going to discuss some questions about the limiting reagent. Let's come first, production of ammonia from nitrogen and hydrogen. And the stoichiometry equation is 1 mole of nitrogen plus 3 mole of hydrogen gives rise to 2 mole of ammonia. Given the feed mixture contain nitrogen 60 kilomole and hydrogen 180 kilomole. Now we have to find out what is the limiting reagent. As per the stoichiometric proportion, nitrogen to hydrogen each 1:3, that is the ratio of coefficient. The coefficient of nitrogen is 1 in the equation and the coefficient of hydrogen is 3. So the stoichiometric proportion is 1:3. And the feed ratio of nitrogen to hydrogen, in the feed nitrogen is 60 and hydrogen is 180. So the feed ratio of nitrogen to hydrogen is 1:3. So the stoichiometric proportion is equal to the feed proportion. That's why there is no limiting reagent. Now let's come to the second example. In the second example, the same thing, the production of ammonia from nitrogen to hydrogen. The stoichiometric equation is 1 mole of nitrogen plus 3 mole of hydrogen gives rise to 2 mole of ammonia. But in here, the feed mixture contains 60 mole of nitrogen and 200 kilomole of hydrogen. So again we have to calculate the stoichiometric proportion. In the stoichiometric proportion, we have to take the coefficient of nitrogen in the equation, that is 1, divided by the stoichiometric coefficient of hydrogen in the reaction, that is 3. So the stoichiometric proportion is 1 by 3 or 1:3. Now the feed proportion of nitrogen to hydrogen, nitrogen is given 60 whereas hydrogen is given 200. So dividing 60 in the upper and lower, we get 1 divided by 3.3. Now we have to compare the stoichiometric proportion and feed proportion. We find that the hydrogen present in the feed mixture higher than the stoichiometric proportion, means 3.3 is higher than 3. That's why hydrogen is higher in feed. So hydrogen is the excess agent and nitrogen in the limiting agent. While calculating the limiting agent, we have to always see in the feed mixture whether the component is higher or lower. If the component is higher, then that is the excess agent, and if the component is lower, then that is the limiting agent. Let's come to the next example. Again, the production of ammonia from nitrogen and hydrogen. The stoichiometric equation is 1 mole of nitrogen plus 3 mole of hydrogen gives rise to 2 mole of ammonia. The feed mixture given here is nitrogen is 60 kilomole and hydrogen is 150 kilomole. Stoichiometric proportion is 1 by 3. Now let's come to the feed proportion. In the feed proportion, nitrogen is given 60 and hydrogen is given 150. So we have to divide 60 in the numerator and denominator. So what we get? 1 divided by 150 divided by 60. So dividing 150 by 60, we get 2.5. Now we have to compare whether the hydrogen is higher or nitrogen is higher. 1 is same. Now 2.5 and 3. We know 3 is greater than 2.5. What is our feed? Feed is 2.5. So here the feed is less than the stoichiometric proportion. So if the feed amount is less, then this component is the limiting reagent. So here hydrogen is the limiting agent and nitrogen is the excess agent. Now let's come to the next example. In the next example, again the production of ammonia from nitrogen and hydrogen. Here the question is product. Means here the question, the stream for product is given. In the product stream, nitrogen is present 10 kilomole, ammonia is present 20 kilomole, and hydrogen is present 20 kilomole. So H product stream is given. The nitrogen present in the product stream is the unreacted nitrogen, and the hydrogen present in product stream is unreacted hydrogen. Now we know that 2 mole of ammonia will form from 1 mole of nitrogen. So 20 kilomole of ammonia is formed from 10 kilomole of nitrogen. Similarly, 2 mole of ammonia requires 3 mole of hydrogen to react. So 20 mole of ammonia required 30 kilomole of hydrogen. Means 10 mole of nitrogen has to react to produce 20 mole of ammonia. Similarly, 30 mole of hydrogen has to react to produce 20 mole of ammonia. So the total nitrogen given in the feed is the nitrogen that is reacted and the nitrogen that is unreacted or extra. So reacted nitrogen is 10 kilomole and extra is here 10. So total nitrogen in the feed is 20. Similarly, total hydrogen in the feed equal to reacted hydrogen plus unreacted or extra hydrogen present in product. So reacted hydrogen is 30, reacted hydrogen is 30 and unreacted hydrogen that is 20. So total we got 50 mole. Now the stoichiometric proportion we know 1:3. Feed proportion of nitrogen to hydrogen, that is 20 divided by 50. So what we have to do? We have to divide 20 in the numerator and denominator. So what we got? 1 divided by 2.5. Now we have to see whether this hydrogen is present higher or lower. So we have to compare. 1 is same, there is no problem. Here we get 2.5 and 3 means 2.5. We know 2.5 is less than 3. So the bottom component is present less in feed, H required by the stoichiometric proportion. So here hydrogen is present less in feed. So hydrogen is the limiting reagent and nitrogen is the excess agent. Now let's come to the another problem. In this problem, the production of carbon dioxide from carbon and oxygen. So the stoichiometric equation is 1 mole of carbon means 1 k atom of carbon plus 1 kilomole of oxygen gives rise to 1 kilomole of carbon dioxide. The feed mixture contains 20 kiloatom of carbon, H, carbon is the atom, and air is given 120 kilomole. Here you can see in the feed air is given but oxygen is not given. So we have to calculate oxygen first. We all know that air contains 21% of oxygen by volume or by mole percentage. So 21 kilomole of oxygen is equivalent to 100 kilomole of air. 120 kilomole of air is equivalent to how much kilomole of air? That is 21 divided by 100 into 120, that is 25.20 kilomole of air. Now we have to calculate 25.20 kilomole of oxygen. Here it has to be oxygen instead of air. Now we have to calculate the stoichiometric proportion of carbon to oxygen. So the coefficient of carbon in the equation is 1 and the coefficient of oxygen in the equation is 1. So it has to be 1:1. The feed proportion, carbon is provided 20 and oxygen we calculated as 25.20. So 20 divided by 25.20. we have to divide 20 in both numerator and denominator. So in the numerator we get 1 and in denominator we get 1.26. Now we have to see which is higher or which is lower in feet. 1 in feet and 1 in stoichiometric proportion, both are equal, so we can't identify. Now 1.26 and 1.26 is greater than 1. It means 1.26 is greater than 1, means the bottom component is higher in feet. So bottom component is oxygen, so oxygen is excess, so carbon is the limiting reagent.